Okay, today we're going to do some segment addition with variables involved. So we're going to review some algebra, and then we'll be using algebra and geometry together to solve some segment addition problems. My goal for you is to be able to use the segment addition postulate with variables to solve equations, to set up and solve equations. All right. In class, the first thing I had students do was I had them do this board work problem as a review of yesterday's lesson. I'm going to pause. I'm going to encourage you to pause now so that you can try the board work. This is how I solved that board work problem. So I got an answer of QS is equal to 37. You can pause here and look at my work or ask me questions if it doesn't make sense. My next board work problem that I did in class was some algebra review. So that's what these problems are. If you I would recommend that you pause the video here and try these problems on your own. So I'll give you a few seconds to pause. This is how I solved these two equations, so I'll let you pause here and take a look at my work. Please talk to me or come to office hours if this amount of algebra does not make sense to you. We're assuming you came into this class with this amount of algebra, so we need to know if you're having trouble with it. The steps that I use for these algebra equations is, first of all, we're going to look at our geometric relationship and set up our equation that way. Once we have an equation from our geometric relationship, then we're going to go to using algebra. So we're going to simplify each side of the equals. In middle school, I know they call it railroad tracks. The equal sign is the middle of the equation, even if it's not physically in the middle of the equation, even if one side seems simpler than the other. But on each side of the equal sign, if there's anything you can add together to combine before you start solving the equation, that makes your life easier. And then if I have x's on both sides, I want to make sure I gather all the x's to one side of the equal sign and all of the other numbers to the other side of the equal sign by adding and subtracting. And then I'm going to solve for x, usually by dividing at that point. So we're going to be using the segment addition postulate for setup, and we're also going to be using midpoint to show that congruence, if I have congruence, then I can set both sides to be the same, both segments to be the same. The length would be the same. Okay, so if I look at number 3, I'll do this one with you. I have information that AC is equal to 23. So I know that because of segment addition, AB plus BC is going to equal AC. Now I'm going to fill in the numbers I know. AB is 9. BC is x minus 2. And AC is 23. I see some like terms over here, so I'm going to set up my railroad tracks. But as I look just on the left of the railroad tracks, I'm going to combine these like terms together. So I have x plus 7 equals 23. Now I'm gathering my x's and my constants together. I have all my x's are on one side already, but I need to get my constants over to the other side. So I'm going to subtract to do that. And so now I have x equals 23 minus 7 would be 16. And then it also asks me, what is BC equal to? So BC equals x minus 2. I now know that x is 16, so BC is going to be 16 minus 2. It's going to be equal to 14. Okay, I'll do one more with you, and then I'll give you some time to try the other ones. So this one, I'm going to set up that DE is 3x minus 1. EF is x plus 6. And then I know that DF is 21. So the first thing I'm going to do is I'm going to use my segment addition postulate. I'm going to say DE plus EF is equal to DF. And then I'm going to fill in what I know, which is 3x minus 1 plus x plus 6. That's the length of EF. And then that's equal to 21. Now I'm going to gather. I'm going to look on the left side of the equal sign, and I'm going to gather my like terms. I have some x's, and then I have some constants. Now I'm still gathering. I want to get my constants over to the other side. So I'm going, well, this was actually on one side of the equal sign. Now I'm going to move my constant over to the other side. So I now have 4x is equal to 16. And the last thing I'm going to do is divide by 4. So x is equal to 4. Now that I know x is equal to 4, I'm going to look at EF. EF is equal to x plus 6. So EF is equal to 4 plus 6, or 10. Okay. Make sure that your geometric setup is correct. So start with the segment addition postulate and then use that to set up the algebraic equation. All right, I'm going to have you pause again, and I'll have you try this one. Here is my work for this setup. I started with the segment addition postulate. I filled in what I knew, and then I gathered my x's to one side of the equal, and I gathered my constants to the other side of the equal. Then I figured out how big HI was. All right, when we know information about the midpoint, we know that JK, since K is the midpoint, we know that JK and KL are the same length. Our information is that JK is 3x minus 5, and that KL is x plus 7. This time we're not going to use the segment addition postulate. This time we're going to use congruence. Since we know that JK is equal to KL because of the midpoint, then we know that 3x minus 5 is equal to x plus 7. I'm going to gather the x's to one side of the equal sign. Remember, the equal sign is the middle of the equation, even if it doesn't look like the middle. It's still the middle of the equation. Now I'm going to gather my constants to one side of the equal sign. And now that I know that 2x is equal to 12, my next step is to divide to get rid of that, 2. So x is equal to 6. Knowing that x is equal to 6, I can put that in and figure out what JL is equal to. So KL would be 6 plus 7, or 13. I could do a check here as well, but I'm pretty sure that that will also give me 13 because they're equal to each other. And so JL, going back to segment addition, JL is equal to JK plus KL. And so JL is equal to 13 plus 13. JL is 26. Oops. J3. JL is 26. Okay. I'm going to give you a moment again to pause, and so you can try number 7. This is my work for number 7. I started by noticing that since n is the midpoint, mn and no are both the same, so they're both 2x minus 10. And I also know from segment addition that mn plus no is going to equal mo. Filled in my numbers, combined my x's and combined my constants. So I wound up with 20 equals 2x minus 2. I added 2 and I solved for x. Once I knew what x was, I figured out what on was by filling it into 2x plus 10. Okay, that's the idea for segment addition. I'm going to stop the video here, but if you can't do the rest of the problems in the notes, then I want to hear from you. So please talk to me if you need to. Thanks so much. Bye.